Okay, today's module 4, lesson 9, writing addition and subtraction expressions. Last week we looked at replacing letters with numbers and replacing numbers with letters. This is similar, kind of, sort of. We're just going to be changing words into expressions, okay? So kind of like deconstructing a word problem, word sentences, and so on to see exactly what words mean in math. Okay, and as soon as I can find the mouse to change the screen. Okay, so let's take a look at example 1. Let's create a bar diagram to show 3 plus 5. Anything that I have in red and bold on the notes, you may want to highlight or underline in your notes because that's what we're focusing on. Those are the words that we're focusing on writing an expression for. So 3 plus 5. So let's see. 1, 2, 3 plus 5. 1, 2, 3, 4, 5. It's a little crooked bar diagram, but you get the idea. So we have 3 plus 5. So far, so good? Ooh, sorry. I didn't mean to take that out from under you. Well, suppose we had to do 5 plus 3. 1, 2, 3, 4, 5. 1, 2, 3. So now we have 5 plus 3. Whoops. Let me straighten that out. Five plus 3. So if we were to draw those super neatly and equally, we would see that both of the bar diagrams are the same size because both bar diagrams equal what? How many units? 8. So are those two expressions equivalent? Yes, they are equivalent. Yes. 3 plus 5 and 5 plus 3 both equal 8. So those are equivalent. They both have a sum. You want to say a sum of 8? You could say that too. You writing this in your notes? This whole sentence should be in your notes, word for word. If I write it on the board, you write it in your notes. What is that called? 3 plus 5, 5 plus 3. We did properties last week. What is that called, everybody? Commutative property of addition. That's right. Order doesn't matter for addition. All right, now let's look at a number increased by 2. So underline where it says a number increased by 2 or highlight it. Now a number. Do we know what the number is? Can the number be anything? So what can I use? Since I don't know what the number is, what can I use? I don't know that it's 5. I don't know what the number is. What do we use when we don't know the value? We could use a variable. Since it's a number, we could just use n or x or a. Let's use n for number. So I have a number. How would I write increased by 2? What operation would be for increased? Right, n plus 2. So that's an expression, a number increased by 2. Now, we can show that using a model too. But here's the thing. If you noticed, even though I use different colors, what do you notice about all the squares? They're all the same size because each unit equaled 1. So these were all equal values. Back when we did ratios and proportions, all the units had the same value. Do I know if n and 2 are the same value? N could be any number in the world. So it's probably not the same value. So instead of using a square, what we're going to use is a rectangle. And now I can just bring that down and say that that has a value of 2. Or I could bring down 2 units of 1 because that's what we did before. So n plus 2. Could I do it this way? Could I do it that way? 2 plus n, are my bar diagrams the same size? Yeah, so they have the same value. We're going to start seeing it like this. I'm just going to do a little timeout from the lesson. You'll start seeing it like that, where that is n and that is 2. Because remember from when we did our ratios and proportions, the units, the boxes, could have different values, right? So we could say that that one box is equal to 2. And does that show n plus 2? Yes, as long as we label that with a 2, we're good to go. And let's look at example 3. Write an expression. So we're looking for an expression to show the sum of m and k. Sum is what operation? Addition. So how would I write that? Yep. M plus k, or I could write k plus m. The last 3, we were able to write it in any order. How come? What did we say that was called? Right. Commutative property of addition tells us that the order doesn't matter. Okay? Good? Any questions so far? Pretty straightforward. All right, so enough with the addition. What about 10 minus 6? Well, let's draw a bar diagram. So there I have 10. 1, 2, 3, 4, 5, 6. So what do I have? The whole bar shows what I have. So that whole bar equals 10. So I write that on top. I'm not filling anything in. The whole thing is 10. Then I can take away 6. So we draw the bracket on top to indicate that that whole thing equals 10. Okay? So what expression would we use? Right, 10 minus 6. Could we use 6 minus 10? Could we use 6 minus 10? No, how come? Well, it would be a negative number, but would our bar diagrams match? No, our bar diagrams wouldn't match. If we started with 6 and tried to take 10 away, the models would not match. If we started with 6 and tried to take 10 away, the models would not match. So we can't use 6 minus 10. Okay? Any questions on that? All right, let's continue. Yes. Well, that's the problem. We would have 6, and to take away 10, then we would get into different colors, and that's not something we're going to worry about because we're not doing negatives this year. Yeah.
Wouldn't the sum match though?
Right. Addition has different properties than subtraction. Subtraction doesn't follow the same rules as addition. So this would not work. All right, so example number 5. How can we write the expression 3 less than a number? 3 less than a number. So let's think about, what do I have? What is it that I have? What am I starting with? 3 less than a number. What do I have?
N.
I have the number n. So first we want to draw a diagram. So this is what I have. What is this? N. And then I'm going to take away 3. I don't have to draw 3 units. I could just say that that chunk equals 3. I don't have to draw 3 units of 1. We could say that that unit is 1. Remember we did that with our ratios? We decided the value of each unit. So that could be 3. So now that we did the model, what expression would we use? Right, I have n, and I took 3 away. It's 3 less. So n minus 3. Let's look at example 6. I see a couple letters, a couple variables in here now. So the number c is being subtracted from the sum of a and b. So I see subtraction here, and I see addition here. So let's start with that, because the c is being subtracted from the sum. So I need to know the sum first. So how would I write the sum of a and b?
A plus B.
Right, or b plus a. I could write either one of those expressions for the sum of a and b. But now I have to take that and subtract c from it. So I have the sum of a plus b, and I'm subtracting c. Now I could put parentheses around the a and the b, but do I have to? Order of operations tells me I'm going to add those first anyway. Working left to right, I'm going to add first. So I don't have to put those parentheses there. I have the sum of a and b, I have the sum, and then I'm taking away the c. So we can leave it just like that. But now let's look at it a little differently. Number 7, the expression is c minus the sum of a and b. So which is going to come first now? The c, because it's c minus a and b. But wait a minute, if I left it like that, what would I be taking away from the c? Just the a. If I leave it like that, that's c minus a. But I don't want c minus a. I want c minus that sum. So I have to have the parentheses this time. So now I'll do the sum first, and then when I know the sum, then I can take it away from c. Okay? So the parentheses are necessary, because without the parentheses taken away from c, whoops, it means something different. Like we just said, we don't want to take away the a, we want to take away the sum. Just bear with me while I get this to fit. And you could start copying this in your notes. So without the parentheses, a is being taken away from c. Where now the expression says that a plus b should be taken away from c. All right, let's see if it matters. So here is the second expression that we just came up with. Here is the first expression from example 6. Let's see if they're the same. We can replace the variables with numbers. So let's use 1 for a, 2 for b, c with 3. Let's plug them in and see what we get. So c was 3, a was 1, b was 2. C is 3, A is 1, B is 2. All I did was replace the letters with the numbers. We did that last week, like with area and formula, area and volume. So now let's follow our order of operations. We have to do the parentheses first, and I should bring down my symbols correctly. 3 minus 3 is 0. Now I'm going to go left to right. First, the subtraction. 3 minus 1 is 2. Bring down the plus 2. 2 plus 2 is 4. Do the parentheses make a difference? Write this down, please. Do the parentheses make a difference? Yeah! There's a difference between 0 and 4. Those parentheses definitely change the value and the meaning of the equation. Okay? Any questions here? So far, so good? Yeah, here we took A away from C. Where here we took the sum away from C, and that made the difference. Okay? All right, let's keep going. Dry erase boards. I'm actually going to stop the recording now. If you're doing the lesson at home, you can print out the teacher notes or print out the student notes to see what all of the answers are for the exercises.